Good day, this is the Professopher, drwillphd, PhD, and today's Friday, January 13th, 2023. It is 6:21 and 41 seconds, a.m. Eastern Standard Time, and today's research, tractor beam. So let's hop to it here. Researchers create an optical tractor beam that pulls macroscopic objects, expanding laser, pulling beyond the macroscopic scale, to be useful for scientific and space applications. Date January 11, 2023. Source: Optical. Light contains both energy and momentum that can be used for various types of optical manipulation, such as levitation and rotation. Optical tweezers, for example, are commonly used. Scientific instruments that use laser light to hold and manipulate tiny objects such as atoms or cells. And for the last 10 years, scientists have been working on a new type of optical manipulation using laser light to create an optical tractor beam that could pull objects. In previous studies, the light pulling force was too small to pull a macroscopic object, but with the new approach, the light pulling force has a much larger amplitude. In fact, it is more than 3 orders of magnitudes larger than the light pressure used to drive a solar sail, which uses a momentum of photons to exert a small pushing force. The researchers demonstrate that macroscopic graphene composite objects they design can be used for laser pulling in a rarefied gas environment. This type of environment has a pressure much lower than atmospheric pressure. The researcher's technique provides a non-contact and long-distance pulling approach, which may be useful for various scientific experiments. The rarefied gas environment they use to demonstrate the technique is similar to what is found on Mars. Therefore, it might have the potential for one day manipulating vehicles or aircraft on Mars. In the new work, the researchers designed a special graphene composite structure specifically for laser pulling. When irradiated with a laser, the structure creates a reverse temperature difference, meaning that the side facing away from the laser gets hotter. When objects made from the graphene composite structure are irradiated by a laser beam, gas molecules on their backside receive more energy and push the object toward the light source. As combining this with the low air pressure of a rarefied gas environment allowed the researchers to obtain a laser pulling force strong enough to move macroscopic objects. Using a torsional or turning pendulum device made from their graphene composite structure, the researchers demonstrated the laser pulling phenomenon in a way that was visible to the naked eye. The scientific researchers had used a traditional gravity pendulum to quantitatively measure the laser pulling force. Both devices were about 5 centimeters long. They found that the pulling force was more than 3 orders of magnitude larger than the light pressure. In addition, the laser pulling is repeatable, and the force can be tuned by changing the laser power. The researchers caution that this work is only a proof of concept, and that many aspects of this technique would need improving before it would be practical. As, for example, a systematic, theoretical model is needed to accurately predict the laser pulling force for given parameters, including the geometry of object, laser energy, and the surrounding media. They would also like to improve the laser pulling strategy so that it can work for a wider range of air pressures. The work demonstrates that flexible light manipulation of a macroscopic object is feasible when the interactions between the light, object, and medium are carefully controlled. It also shows the complexity of laser-matter interactions and that many phenomena are far from being understood on both macro and micro scales. And this is the Professopher on space science, advanced physics, and mathematics. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.